This is part 2 of Pre-Algebra lesson 10-6, which is systems of equations. We're going to scroll down to number 13. In the previous video, you did 12 and 14. We're going to do 13. Again, I want you to recognize that both of these equations are solved for y. We've got y equals over here, so that makes our work easier. If 2x minus 3 equals y and x minus 2 also equals y, then 2x minus 3 and x minus 2 are equal to each other. And so we're going to create a new equation based upon that. The new equation is 2x minus 3, which is this, equals x minus 2, which is this. And so by doing that, we got rid of the y's and we can solve this new equation. We're going to subtract x from both sides, giving us x minus 3 equals negative 2. Add 3 to both sides, gives us x equals 1. Now that we have solved for x, we need to solve for y. We need to choose one of these two equations to plug in for x. This one looks just a little bit simpler, so I'm going to pick that one. Plug in the one that we said is equal to x, and y equals negative 1. The final answer should be in the form of an ordered pair with the x value first and the y value second, and there's your answer. Okay, number 11 is kind of an odd problem. I just want to show it to you. I'm not sure you'll get anything that looks quite like this on your homework. Again, we've got both equations set equal to y, so we can set the other sides equal to each other. X equals negative x, and you can't really do anything with that because x is already by itself, and it equals negative x. So can anything equal its opposite? Like, can 1 equal negative 1? Can 2 equal negative 2? Can 3 equal negative 3? The answer is just going to keep being no, but there is one thing that could be plugged in there. Do you know what it is? It's 0. 0 does equal negative 0 because negative doesn't apply to 0. So if x equals 0, and then we plug that into one of these equations, I'd pick that one. And you've got your answer right away. So the only thing that would satisfy that is 0, 0. And that's a very strange situation, but I just wanted you to see it. Okay, these problems are from practice B, so you probably get some repeats in the problem numbers. The directions are still solve each system of equations, and these ones are a little bit more difficult. And at first glance, you might think, oh, they start with y, but they are not both solved for y. You see how in this one, y is not by itself on one side of the equation, okay? Well, so all that means is we have to do one more thing. We could very easily solve for y. We can do that by adding x to both sides, giving us y equals x minus 2. So don't consider this equation anymore, and our two equations are now these two. If this equals y and this equals y, then those two things that I boxed equal each other. And that generates a new equation, 2x minus 3 equals x minus 2. And it causes all the y's to go away, no y's over here. And we can solve that. We'll solve that by subtracting x from both sides. 2x minus 1x is x. Bring down the minus 3 equals negative 2. Add 3 to both sides. And x equals 1. Once we've got x, we can solve for y. And I would recommend that you go back to your original equations here and figure out which one you think is simpler to deal with. I'd say they're about equal again. I'm going to copy this one. Y equals 2x minus 3. Plug in 1 for the x. And simplify. Whoops. Plug in 1 for the x. And simplify. And y equals negative 1. Our final answer will be in the form of an ordered pair with x, the x value first and the y value second. Okay, so there was one additional step there. We had to solve this equation for y. Okay, question number 12 presents the same exact kind of situation. This equation is solved for y, and this one is not. So we're going to need to solve the second equation for y. I think I've got enough room to do that right here. The second one, we're going to add x to both sides. That goes away, and y equals x plus 1. There, that didn't take too long. So again, we're not considering this equation anymore. We're considering this one and this one. If this is equal to y and this is equal to y, then those two pieces are equal to each other. 3x minus 1 is equal to x plus 1. The 3x minus 1 came from there. The x plus 1 came from there. Okay, then we will solve for x by subtracting x from both sides, leaving you with 2x minus 1 equals 1. Add 1 to both sides. 2x equals 2. Divide both sides by 2. And x equals 1. Once we have our x value, let's go back to our original equations and choose the simpler of the two. I guess I like this one. Pick whichever one makes you happy. Y equals 3x minus 1. Plug in 1 for the x and simplify. Sorry, mine's kind of jammed in there. And then our final answer is an ordered pair, which is 1, 2. Okay, we're going to set up a couple of word problems, but we're not going to take the time to solve since we've already solved quite a few. 14 says, the sum of two numbers is 24. The second number is 6 less than the first. Find the numbers, write a system of equations, and solve. I kind of like to define my variables. In this case, we have a first number and a second number. First equation should be pretty simple. The sum of two numbers is 24. What would that be? Sum is addition. First number is x, second number is y, and they add up to 24. X plus y equals 24. Then we've got the second number. Second number is y. Is, remember in math, linking verbs is, are, was, were are often the equal sign. The second number is 6 less than the first. The first number is x. 6 less than that would be x minus 6. And we're just going to set it up for today. You've solved a bunch of them already. Then number 15. Carrie and Luke biked a total of 18 miles in one weekend. Carrie biked 4 miles more than Luke. How far did each bike? Write a system of equations. Again, I like to define my variables, and I like x and y, but in this case, I think it's going to help me to keep it straight if I call them k and l. K being the distance that Carrie biked, and L being the distance that Luke biked. Again, the first equation shouldn't be too hard. Carrie and Luke biked a total of 18 miles. So Carrie plus Luke equals 18. Carrie biked 4 miles more than Luke. So Carrie equals Luke plus 4. And then you could solve both of those for K and then solve for the system.